So let's switch now to the 5-axis, talking about the composites. We had some great enhancements already shown in 2025.4 with new patterns, not relying on knitted surfaces or construction surfaces to define the toolpath. So we'll see more of this with some update on the UI to kind of help the user on providing better control and a better experience creating the toolpath. So for this, we'll switch to Alessandro, who's going to demonstrate this in the system. Alessandro, ready?
Yes, thank you, Olivier. So, about this new release, EEdge2026.1, you will find composite modernization, which is the result of the last development we have made in the last years when working on the 5-axis remachining. We reused this technology for composite, and what we modernized is, first of all, the algorithm to produce the toolpath, and this goal is the one that is now able to simplify the user experience of this cycle, the 5-axis composite, which is one of the most aged in the context of 5-axis cycles of EEdge. So we can start talking about the most common end user stories, which is repeatable on this part where we have this groove to be machined. So the end user is obliged to create what Olivier mentioned, so the knitted surface to drive the toolpath. This, of course, is not an easy step because the end user must go inside the modeling ribbon bar, select the proper topology we have for the knitted surface, and then he must pick every face where the toolpath will go to exist. So we can understand that by clicking any face here and there, we are proposing to the end user one prone to error approach. So we decided to leverage on the already available information which are inside the freeform part. Indeed, we can see that by clicking any face here and there, we must neglect some small faces, and so the result can be not accurate. So what about the content of the freeform? So in this case, it's natural to include all the faces of the groove as a part, so the green ones. And now we can go to the composite UI to start from the changes we made in 26.1. First of all, we introduced a new parameter which is called pattern method, and this parameter is needed to filter and group all the machining patterns we have before. Originally we have 7 patterns, and now we are going to have more and more. And we filter these patterns by the method used for creating the cut passes. We can find 4 methods. For example, here we can find the method based on slicing planes that can be parallel or perpendicular to a spine curve. We can find also the most aged ones, which are the ones that are driven by a drive surface. We can also observe the ones which are driven by profiles, and we decided to split the 3D offset and single pass into 2 different machining patterns. But we can also see the last one we introduced, which are called the central pass offset and flow, again from the 5-axis remachining development. In the previous version, you can find the contour offset, But if we drive the toolpath generation from the border between part and check, we can apply some processing to extract some relevant references, like, for example, the central line of the machined area. So let's explore the new toolpath we can achieve by using the central path offset. In this case, we can see that the system extracted the central line of the machined area and then is able to compute constant 3D offset by this central line. This kind of machining pattern, of course, can fit for this kind of part we are showing now. And what's new is also the introduction of new options which can be considered as incremental improvement. One of them is the pass position limitation. We can machine the whole surface like we did in this toolpath, but we can also limit the toolpath existence by a distance, as I already prepared in this example. This incremental improvement is also shared with the other machining pattern driven by profiles. So in this case, we can go to observe some relevant profiles we have on the outer diameter of the part, so the blue ones, and we can observe the toolpath produced by the limit distance here applied to the drive profiles machining pattern. So we can limit the toolpath again by distance from the given profile here used. Another incremental improvement is the capability to reorder the passes by region or by level, which is commonly useful for 5-axis machining. In this case, we can observe this toolpath where the passes are ordered giving priority to the region. So we can see that the toolpath is starting machining one side, then moving to the other one, and so on. The other way of reordering the passes is by level. We can analyze also this other toolpath, and we can see that now the toolpath reorder is by level, so alternating one side to the other side up to the end of this limited toolpath by distance. So we can move on. Again, just looking at the result of the drive profiles, and we can observe some defects that we are going to improve in the next releases, but we already improved in 26.1. Indeed, if we imagine to cut the full area in between these drive profiles, we can observe that the width of the channel is variable, thus producing some collapsing offset, which at the end will generate relevant cusp 8 in the corners, like we can see from the stock automation preview. So what's new is the second machining pattern. We can go to the UI. It's called flow, and it's the same that we can find in the 5-axis remachining. And you can find it again inside the machining pattern freeform part driven. Flow is this one. And this is a very important machining pattern because it's designed to minimize the cut passes interruption. Just to as you can see here, avoid the interrupted passes we have on the previous toolpath produced by the central pass offset, where the width of the channel is becoming smaller than what we have on the starting side. So we can simulate it. And we can observe that this kind of toolpath was not producible by the knitted surface, because in this case we have not let's say a basic topology offered by the knitted modeling commands, so the for border or the closed. Here we have a groove which has multiple branches, so there is not let's say a basic topology able to produce this kind of machining pattern without any interruption. I would like to talk more about also the quality of this new machining pattern, central pass, offset and flow, so we can jump to another part where I can also recap what I explained now. So let's go to this one, and we can refer to this simple toolpath that I created on the set of surfaces we have here. So this is a tubular domain. We can observe the previous toolpath created by the knitted surface approach, and we can see some defects here and there. We can also highlight them. For example, we can see that the toolpath is not regular when the tool is called to move across some sharp edges that can exist on the machined surface. But also we can see that the toolpath is interrupted in the border between the part and check, because we have here a bitangency condition. So flow machining pattern is not affected by this limitation, so we can see it. And we can observe, of course, the best toolpath quality we can achieve without those interruptions in the bitangency on the outer border, but we can also observe the continuity of the passes and the regularity on the sharp edges. Moreover, if we have a look to the freeform target, we can see that now composite using flow machining pattern and central pass offset can machine multiple targets in the same operation. Indeed, here we see the two eyes, but also this other detail I am able to machine with a variable stepover produced by the flow machining pattern. So that's it for me. I would like to have a small recap. If we have a look to this other target, here we can compare the three freeform part-driven machining pattern. This is the legacy offset, we can see here, which is commonly producing a 3D constant stepover. This is the central line pass offset. We can observe from also this other side. We can see that the system, no matter what the shape of the area to be machined, extract the central line, extend up to the border and produce 3D offset passes from it. And last one is flow, which produce morphing passes between the central line and the outer border. So you can play with this new machining pattern referring to the last training script you will find, which is the 207 for composite modernization. Okay, I leave some room for any question.
I have a question, Alessandro.
Yeah.
So first, really impressive, the quality of the toolpath, smoothness of the toolpath, path distribution looks very good. I believe you have you filed a patent on some of these methods, no? Haven't you?
Yes, good question. We have a patent for a new machining pattern that is going to be introduced in the next release.
Okay.
And we are talking about 26.2, and the pattern will be called contour variable offset, and will be a sort of mixed pattern between flow
It's not
and
spoiled.
the contour offset. Okay,
It's
okay.
not spoiled. Okay, excellent. It's a great innovation. Thank you. Any other question? Okay, so time to switch to the next topic. We're running a bit long, but I think it's interesting for everyone. So